Okay, so first of all, thanks for attending this session on NServiceBus and the Windows Azure Platform. For those of you who don't know me, my name is Yves Goulev. I work for Capgemini in Belgium, and of course I'm Windows Azure MVP, as you guys are as well. The goal of this presentation is to show you how Windows Azure and the NServiceBus framework together allow you to simplify the building of distributed applications. In case you have any questions during the talk, because we are such a small group of people anyway, you can certainly just unmute yourself and interrupt me with a question that you may have. Okay? So please feel free, and if you don't have a mic, just simply type in the Q&A section and I will try to answer your question immediately. Okay. The agenda that I want to cover in this session is, first of all, a basic introduction of what NServiceBus is and why it is so suited for Azure development. Right? I myself have started as a member of the NServiceBus development team because I needed a framework like it to run on Azure, to make building of distributed systems a little bit easier. Once I've introduced you to what NServiceBus actually is, I will continue with the number of communication patterns that the framework itself supports. This is limited for a reason. I will discuss that later. And then also I will take you through the steps that it requires to build a basic NServiceBus application. This is not specifically Azure. This is the same if you develop on-prem or if you build in the cloud. It's actually just the same. But then afterwards I will give you an overview of the Azure-specific implementation details. I assume that we will have a lot of questions during this section because you know Azure has some different semantics than you might be used to on-premises. And so a couple of things are different. And then in the end I want to show you a demo. This slide deck originally was for a sort of hands-on lab. I don't think we have time to all play with it today, and it's not even suitable to do something like that online. But I will just give you a demonstration of how or what kind of code is required to build a distributed application on Azure using NServiceBus. So to get started, I want to introduce you to the NServiceBus framework. For the people that have just joined, if you have any questions, simply unmute yourself and interrupt me. We are a small group, so it's perfectly feasible to do so. Okay, so what is a service bus? Let me start with that. I think you guys are probably all aware of this, but a service bus is an architectural pattern. Right? It's intended to simplify the communication of different services in a system and their consumers. Now, typically what you will see in a service bus pattern is that you will see loose coupled messaging. Most of the time, this loose coupling is definitely in the space, in location where the services are deployed. Services and their consumers should not know where the other party is. This is typically reached by means of separating contracts or defining contracts between the different components. But also very often in a true service bus there is a separation in time. Usually this is achieved by some means of durable communication mechanism between the services and their consumers. Very often queues, might also be more advanced patterns like topics, for example, or message boxes, and several options. Now, even though there is a pattern for building loosely coupled and distributed systems, it still takes a lot of effort from development teams to actually build distributed applications on top of them. they have to take into account a lot of things, included how do you handle messages in multi-threaded fashion, how do you appropriately deal with addressing, routing, transaction scopes, correlations between messages, headers, serialization, version tolerance if you have a very big system, etc., 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 etc. There is quite a lot of stuff that you need to implement just simply because you're working in a large distributed environment. And the basic idea that the development team of NServiceBus has is that all of this is actually a distraction from what the developer really wants to do. We think that developers or development teams in general want to focus on their application, the business logic in their application, and not necessarily all of the plumbing that is required to make a distributed system. So the main goal of NServiceBus is actually to provide a logical service bus. So in effect, it's a framework that takes away all of those distractions. It will implement them in an abstract and general way on top of some kind of infrastructure. This infrastructure can be very basic. All that we actually need to make a distributed system work is a durable communication mechanism like queues and storage. That's all. That's anything we need. But we are not limited to those, so we can also run on top of other systems or brokers or products or whatever you buy. The basic idea of NServiceBus is that we provide a framework, a skeleton, that can be implemented by several types of infrastructures. Out of the box, it comes with Amazon Q for on-prem, today also with Azure Storage Queues and Fabric Queues. And there is also, I think, an option by default to use FTP as a communication mechanism. But I know of products that also use, projects that also use products like ActiveMQ and other queuing mechanisms. So there is quite a lot of possibilities to run underneath NServiceBus. The ambitions of the framework are to make development of scalable and distributed applications very, very simple, so that developers can focus on what they really care about, the business domain and the logic that they are working in on a day-to-day basis. So that's our ambition. So it's a framework, it's not a product, it's not a runtime, it's simply libraries that you can use inside of your application to provide the service bus pattern on top of some kind of infrastructure. So without an infrastructure, the framework itself does nothing. But we have the ability to switch infrastructures depending on where you deploy or depending on what your preferences are. Now, the framework itself is what we call the core. So the core is basically nothing more than a set of interfaces and base implementations that will be fulfilled by certain implementation. Right? Besides what we call the core, there are also some processes or implementation of processes that you get out of the box. For Windows Azure, this is, for example, the dynamic host. So I'll come back to that one later, but it allows you to host multiple logical worker roles on one instance. And you also have the timeout manager. This is something that I will talk about a little bit later, but it's kind of a scheduler for timing out messages. And there are other processes inside the framework as well, but those are mainly for on-premises development. The majority of them are there to overcome limitations of communication with Amazon Q over firewalls. Of course, in Windows Azure, those limitations have been solved for us. So all of those other processes are not necessary. But I do envision that in the future there will be more out-of-the-box processes that people can leverage. Okay, now that's a bit of a high level overview of what NServiceBus is and why that I have started development on it. But it's also very important to see the relationship with Azure itself. I think both Windows Azure and NServiceBus have at their basics, they have the same goal. We want to make it easy to build scalable distributed applications. Now, we have a different level. Of course, Windows Azure focuses on abstracting away the infrastructure and all of the hard bits that are required to make such a scalable distributed application run from a data center and infrastructure point of view, while NServiceBus wants to take away the difficulties in building such a distributed application from an application infrastructure level. Besides that we share the common goal, it also offers all the primitives that NServiceBus requires. So there are different means even to build durable queues, and there is storage that is at least reliable and semi-transactional as well. So all of the needs that a framework like NServiceBus has to make systems operational in Azure are also available, so they're a perfect match. Okay, so if you guys have any questions on that, it's a very brief introduction of what NServiceBus is. So remember, it's a framework, it's not a product, it's not a service, it doesn't run on itself. It is implemented in various ways, and those ways are interchangeable. So today you might build an application on top of Amazon Q, and tomorrow it can run on top of Azure Storage Queues. It's roughly the same. Okay. The framework itself is very much focused on communication patterns between different components in a system. And I want to talk you through those components, and also very important is why we only support a limited amount of communication patterns. Now, NServiceBus is very often described as a moderately opinionated framework. Now, I want to scratch the moderately part. In fact, we are pretty opinionated. And we do expect people to build their software in a certain way, or otherwise the framework will actually fight you a little bit. One of those rules that we do follow is that all components are completely autonomous, which means that they share nothing besides a contract. Right? In effect, the guidance is that every single message handler or every single component runs in its own process. It has its own queue, it has its own data store, it has its own everything. Different components never share any resources, just simply to be highly available, or at least, sorry, to be highly distributable. Now, some people take this very literally and will effectively make a separate process for every message handler. And if you translate this literally to the Windows Azure environment, this would actually mean that you would create a separate role for every single message handler. Now you can see that I got a lot of objections when designing the system like that the first time, because even though it's an ideal for highly scalable and distributable applications, it's also very costly for a lot of design systems today. So that's something that I addressed by adding the dynamic host to the framework as well. Second rule that we follow is that communication between components is always message-based, is asynchronous, it must be queued, and the queue must be durable. So these are things that we just simply assume. And maybe also important is that we also assume some kind of transactionality for the queues. So a completely transactionless environment without something like peak lock mechanisms, I don't think that we can support it from a NServiceBus point of view. And furthermore, we only support a handful of communication patterns like I discussed on purpose, because we want to push them in a certain direction. We want to make sure they design in a certain way. This also causes that NServiceBus is very opinionated towards the architectural style that you follow. I've seen today that there was a lot of discussion on Twitter on the CQRS architecture. Now, this is one of the architecture that we, with NServiceBus, definitely promote, together with event-driven architectures. Those are the two most common architectures that I see when people actually use NServiceBus. If you want to follow different architectural styles, I think NServiceBus will fight you, and then you can better look at other frameworks or other products and use them without using NServiceBus. So we are pretty opinionated. We want the components to be standalone. They share nothing. We only support one way of communication, and we only support a handful of patterns. Right? So if you can't live with those things in your system for whatever reason, then NServiceBus is not a framework to go. Okay, now let me take you to the patterns that we do support. The first one is pretty obvious. We allow people to do one-way queued communication. Right? In NServiceBus terms, we call this send. If you look at the API one day, you will see that we have an iBus interface which contains a few methods, and one of those methods is called send, and it allows you to send a certain message to a certain destination. You can specify the destination if you want to. In concreto, this means the destination responds to a logical queue name. Right? And the queue can be read by one or multiple workers or instances. So that's pretty common. Second pattern that we also support is full duplex. Similar to request reply, but not really the same. In the API, we call it send and reply. So the client can send a message to a certain destination, and the processor of that message will be able to simply call reply on the bus API, and the framework will figure out where the message came from and send it back. Now, this is the kind of thing that the framework abstracts for developers. Is how do you handle correlation of messages? How does it know where the message came from, etc. All of those things is something that the developer does not have to think about. Also, maybe a small remark, the framework itself will also create all of the underlying infrastructure for the developers. So if a certain queue does not exist, it will automatically create it. If the framework requires database tables, no matter what the store is, it will always auto-create schemas in databases or tables in table storage or whatever that the underlying infrastructure is. All of those kinds of things, all of those kinds of setup concerns, all of those are being done by the NServiceBus framework without requiring the attention of the developer. Of course, if they want to intercept, they can, right? But we don't expect them to. But there is one exception. We will never create destination queues. Because if there is nobody listening at the other side, then that's actually a pretty big bug in your system. So we do require you either to build a process that will start and listen on that certain destination queue, and in that case the queue will be auto-created by the listener, or we want you to create the queues manually. Right? For some queues there are no listeners, or not always, like for example an error queue or a dead letter queue. In that case we want you to create the queue yourself. Okay, so with two patterns now, send and full duplex. The third pattern that we also support obviously is pub sub. Right? This is probably the most important pattern in the communication styles that NServiceBus actually support. Important is that you need to know is that every instance in the communication chain will keep a copy of the subscribers. So there is no central intermediary, or there is no central system that actually keeps track of this. Every single participant in the communication will keep track of who is interested in events from the instance itself, and will manage it also itself. So that everything is distributed across the different participants in the communication, and there is no middleman. Okay, so that's why it's a framework, and it's also embedded in every, or at least almost every part of the communication interaction of all the different components. I assume you guys all know what one-way, full duplex, and pub-sub is. I'm not going to dive into these too deeply. One of the more interesting patterns that we support in NServiceBus is what is called the Saga pattern. In the Saga pattern, this is a pattern intended to track states of long-running communication, right? But in that sense, that every partner in the communication chain will keep track of its own piece of the communication. Right? Those orange circles that you see on the diagram, those are the sagas. Those are stateful objects stored in a persistent store, like, for example, table storage. And if you combine all of the sagas together, you actually would get a complete view of the communication interaction between all of the components. In some sense, the Saga pattern is often seen as an alternative for a central workflow or BPM solution. Right? But with that big difference is that you do not have a central location where you can see the workflow or where you can see the communication interaction in one nice image. But all of the pieces of the communication are spread across different participants. Right? So that is basically the Saga pattern states or partner states that is being tracked by every individual or every instance inside the communication. Okay, and then the final pattern that we support is something that we call the data bus. Sometimes, or at least in every system, you have a few of these. You will have messages that have properties that get rather large and that often exceed the capacity of the queue. Think about a message with an image attached, or a message with a video attached, or a message with a file attached. Now, in that case, NServiceBus will do a little trick. So it will seem for the client and the consumer of the message as one message that is being sent across a queue. But in fact, NServiceBus will split off the big properties, serialize them into some kind of file store. This can be blob storage in Azure, but this could also be shared on-prem or other means of storage. And it will take the big parts of the message through what we call the data bus, and the regular message information will be passed through the queue. One of the difficulties with this pattern is that often these file stores do not have transactional semantics in no way, usually. So we do have to solve this problem in a way that is acceptable. So what we do is, on every message that has database properties, we will force you to specify a certain timeout time. For example, 1 hour or 24 hours or a few days, whatever. And after this timeout has expired, we will remove the big chunks of data on the file store. And we assume that the message has been processed in that time frame. Okay, so those are the only patterns that we support. one way, full duplex, pub/sub, sagas, and the data bus, and that's it. Okay, we don't have any other communication patterns that we do. If you want other communication patterns, you can look at other frameworks that are more suitable for doing that kind of thing. Okay. Any questions on this so far? No? Okay, then I'll continue with the next step. The next step is actually showing how people use NServiceBus and what the steps are that the developer needs to do to build a big or at least a distributable system. Now, first step is, well, it will not really be a surprise to you guys, but the first step is defining a message contract between the components that interact with one another. We require people to simply implement POCO classes, but with an interface coming from NServiceBus. It's in a special library that is supposed to never change. It's called NServiceBus.dll, and the interface is called iMessage. It's simply a market interface that will make the framework do all of its magic, requiring subscriptions, requiring addressing, etc. But we just simply need a way to mark what is part of the contract. Now, in version 3.0 release, you can specify your own interface if you like. Right? This was one of the, let's call it, problems that we saw in the past, is that contracts do have reference to a certain version of NServiceBus, and in the long run this might cause problems if you want to do partial upgrades, or if you want to host one part of your system with NServiceBus 2.0 and another part with NServiceBus 3.0, etc. So this is something that we are swapping out, and if you want to, you can use your own interface type to mark messages. Okay, so I will continue with iMessage, but just remember that you can just simply remove the dependency of your contracts on NServiceBus completely if you want. Okay, so once the contract has been defined, like in this case an event called image uploaded with some properties, there is also some component or some logic that needs to be implemented for handling those messages. In order to do this, all that you need to do is implement a class which has iHandleMessages of T implementation. Right? This class needs to be in an assembly. That is, here it says it's referenced by a process that has a bus configured, but it doesn't even have to be referenced. It has to be detectable. So if it's in, for example, the bin folder of a process that has a bus configured, NServiceBus will automatically pick it up and start running the message handler. Right? So the code that you see here is literally the only code that you have to implement in order to handle a certain message. It just has to be somewhere near a process, detectable for a process that has a bus configured. Okay, so our goal really is to make development of distributable applications as simple as possible, and we don't really want developers to write any NServiceBus code. Right? Just implement an interface and you're good to go. Okay. For sending or publishing messages, all that you actually need is an instance of the iBus implementation. This iBus implementation can be used from anywhere. In this case, it's used inside a message handler, but this doesn't really have to be the case, as you'll see later in the demo. But important to know is that NServiceBus does use an IOC container internally. And we also kind of assume that everything will be resolved through this container. You can also specify your own container, so if you have an application with an existing IOC container, you can just simply inject it in a NServiceBus. It will play nicely with almost any container that's available in the ecosystem. But we do assume that instances are injectable into the components that are required for us to run, like for example message handlers. So everywhere where you want to use a bus, just simply accept the bus through constructor type, for example, put it in a local variable, and then call publish or send or whatever on it. All you need to do in order to send or publish a message is just simply create a new instance and fill up the business properties of those instances, but you never have to deal with any kind of metadata setting or whatever. There's nothing that you need to do in order to make sure that that message is completely filled up. All of the headers are managed. For example, identity can be propagated across different components, etc. That's all automated for you. Okay, so it will not be a surprise to you now I say this probably that we use a lot of reflection and a lot of stack walking behind the scenes to figure out in what context certain messages being sent or received or being replied. But the goal of the framework is to figure this out for you as a developer so that you don't have to think about it. All that you want to do is send a, well, the terminal has been created message and you're good to go. Okay, basically this is the only code that you should be writing as a developer. So you define a contract, you define a message handler, and you send or publish the message from somewhere. And all of that is basically the only thing that you need to do from a code perspective. For Windows Azure development today, you do need to specify the routing. So this is something that has to be added to a config section in your web config or your app config file, where you say that all messages in a certain assembly need to be sent to a certain endpoint. An endpoint in this case is a logical queue name. This is true in Windows Azure. In the on-prem version, there will be automatic routing detection, where that whenever that component starts, they will talk to each other, figure out what messages that they can handle and what they will be sending, and the routing will be configured automatically. But this relies quite hard on another open source framework internally, RavenDB, and it also requires, as I'm not mistaken, UDP communication between the different components. And both RavenDB and the UDP communication do pose a problem today in Windows Azure, so it's something that I, for now, cannot automatically do. Right? I know RavenDB can run in Azure, but in order to do so, it requires a persistent disk, so you need to push a certain amount of work back to the developer to make sure that the disk is mounted, etc. So that's why I personally chose not to go further with RavenDB and do everything on top of table storage, etc. But this has the side effect that I do have to ask from the developer to specify the endpoint names where a certain message has to arrive. Okay, so that's basically it. We want to make NServiceBus as easy as possible to use for developer. It has a lot of magic behind the scene. But what you do need to remember is that all of this magic is replaceable. So basically, NServiceBus core is a set of interfaces and a set of base implementations on top of these interfaces, but it doesn't force you in any direction, whatever. Right? By default, NServiceBus will be implemented by using MSMQ as a queuing mechanism. It will use Autofac as a container. It will use Log4net as a logging mechanism. And for previous versions, all persistence is done through an Hibernate. But in current or latest version, this will be RavenDB. Right? Now, in Azure, not all of these really make sense. So I simply replaced those basic implementations with other Azure-specific implementations, which we will discuss later. Okay. Now, it is possible for you to specify the composition of the bus manually, if you like. This is done through a Fluent API in code, and the base starting point for the Fluent API is a class called configure. You have there a method called widthWeb or width with all kinds of overloads. This specifies to NServiceBus where it needs to find all of the assemblies that it will have to parse and reflect upon to figure out what are message handlers, what are sagas, what are destinations, etc. The IRC container can also be specified. I chose here to use a default builder, which is Artifact behind the scenes. You don't have to specify it in this case, because if you don't, it will be Artifact anyway. But you can switch out any kind of IRC container. So if you prefer Unity, or if you prefer Structure Map, or you prefer Ninject, or whatever, you can just plug it in here. In this case, I also specified Log4net as a logging mechanism. I use Log4net here in this case with an Azure appender to make sure that the Log4net entries are redirected to the diagnostics manager. Next line, for example, is the configuration source, which is in this case the Azure configuration source, which will use service configuration files. The message queue can be specified, the serializer can be specified, and then we have a few other specifications which are actually regular config. The queue per instance one will ensure that every instance that is created inside a role will get its own specific queue. If you don't specify this, they will share the queue like a worker implementation. The unicast bus will also work in a transactional way. Now, you do have to keep in mind that in Windows Azure this transactional way means peak lock way, so it's not truly transactional. So you have to take that into account when building implementations, that you're actually never inside a transaction. On-prem, this really does mean that you are in a DTC context and that everything is truly transactional. Now, this is an option. This is a way to manually choose all of the parts of a bus in a process. But you don't really have to do this, of course, because, well, this is quite a lot of code for you to write, so we don't want you to do that. In order to make this a little bit simpler and default for everyone, we have what we call predefined roles and profiles. A role is actually this section here called as a worker in this case, which specifies to a certain instance of a bus how it needs to configure itself. So in Windows Azure, this looks a little bit similar to how you're used to define roles. You just inherit a class from a role entry point. Do remark that this is the NServiceBus hosting Azure role entry point and not the same role entry point as you can find in the runtime. But this one does inherit from the Azure role entry point, of course. Furthermore, you need to have one class which implements the interface called I configure this endpoint, which specifies the role. I will come back later to all the different kinds of roles that we have, but as a worker is probably going to be the most common one in Windows Azure. Now, those two lines are the only ones required to set up the bus in a conventional or a agreed way. But if you do want to step out of the conventions or add features or remove features, you still can by adding a class with the implementation of I want custom initialization. In that case, you get an init method that will be called at the appropriate time, and you can again use the configure the configure class in order to specify additional features or remove features that are added by default. So in this case, for example, I add the Azure Databus implementation because Databus is something that is not standard in every single implementation and needs to be added. Okay. So basically that's it. So as a developer in a process, you need to first specify message. You need to have a class which implements I handle messages of T, and you need to specify the role of the role entry point in this case, right? Which is specified as a worker. In config, the role has a friend called a profile, and the profile will allow you to switch out certain implementations just based on config. In the Azure implementation, I will, for example, allow you to choose between storage as a queuing mechanism or App Fabric as a queuing mechanism. So that's a profile that you specify. I also allow you to choose for subscriptions and for Saga storage, for example, to choose between table storage and SQL Azure. Right? Those two are available. And also for logging output, I have a profile called development and a profile called production. In development, I personally find it very useful to see all of the output in Visual Studio, in the console of Visual Studio, instead of having to look in the in development storage. But on Azure, you of course want to push everything back to the diagnostics manager and read it from storage. So those are different kinds of profiles. Also very important to know if you are, for example, team lead on a services project, you can perfectly create these things yourself. Right? It's pretty simple to build roles and profiles. It all works on top of the configure class, the configure fluent API to specify what you exactly want. If you have some kind of need that is not by default there, but you still want to make it magical for your developers, you can just simply implement your own role and profiles. Okay, any questions or remarks so far?
Yeah, this is Clement.
Yes, Clement.
Do you have so I've seen your config being in kind of fluid API style. Do you have config files as well?
Yes. I will come back to that in the next section because it's a little bit special in Azure. But in fact, you can specify all kind of configuration settings in both web config as well as service configuration file. But if you don't specify anything, NServiceBus will configure itself for use on development storage. Okay.
And so, one more.
Yeah. Shoot.
Yeah, one more question. There's I've watched the previous section with the sagas, and now you get this here, and then we're talking config. So effectively, when I understand this right, NServiceBus creates a peer-to-peer structure with there's nothing that's really a centralized view of it, right?
Yes, correct.
Okay. So there is a notion of some storage that you have, but that's kind of on a node per node basis.
Yes.
How do you wire stuff up? Like, what's your notion of addressing? Do you give guidelines around that, or is that just whatever the application architect feels like?
Can you repeat the question because I don't understand the notion of addressing?
So when you build a solution and you have these queues that you create, or these communication paths that you create, do you give any guidance around this, or do you have any frameworky constraints around this, or is it really up to you to go and define, say, my QA is the queue that's assigned to this particular worker, and there's a QA reply that's a reply queue from that worker? Is there some abstraction on top of this?
There are indeed some rules that NServiceBus will enforce when it starts up. So it will validate parts of the addressing configuration and tell you if you do stupid things or not. Are there any guidelines on it? I assume so, but I would have to look on Uri's material for that, because that's actually general for all implementations. So it's not something specific for Azure or not something specific for Amazon Q. It's pretty general. But But it's always the case, at least in Azure it is, that the queues are owned by the listening process. Right? There are no two queues for every process. It's only one, an input queue. And messages will be directly sent to the queue of the other node. Does that answer your question?
Yeah. Okay. Yeah. Okay. So effectively, you're constraining down the cardinality of queues just by virtue of your whole, like, your process model is already making some assumptions about cardinality of the artifacts.
Absolutely. Yes.
Okay. So that's
yeah. Shoot. Okay, and we will also enforce it when startup. So if you do stupid things, we will just throw an exception and tell you that you do stupid things. Okay, so we're pretty opinionated in what we will allow or not, but we do have those assumptions that you build your system in a certain kind of way. Okay, any more questions? No? Okay. The next step is probably the most interesting, because by now it has been, I think, pretty straightforward. Actually, that's what we try to achieve, that anybody can build a distributed system and do it in a proper way. But there are some things specific to Azure that I need to cover. What you can do, what is in the framework, what special kind of considerations that I took while developing certain implementations. I assume that you do have a couple of questions on this, so shoot whenever you feel like it. The first implementation that I want to cover is the configuration source. So, NServiceBus never assumes that its configuration is in one specific spot. By default, there is something that we call the default configuration source, which will most logically be based on the config file of the process, so appconfig or webconfig. But you can specify any configuration source you like to get your configuration from anywhere. And therefore, I built what I call the Azure configuration source. This is a configuration source intended to be used when you run on Azure. Right? By default, it uses configuration sections from appconfig and webconfig files, but you can override these settings from the service configuration file. So it's a two-step configuration process. First, I will read config sections from appconfig, and then I will, by convention, override settings from the service configuration file. And the convention is as follows. So if you have an XML tag key and you have an attribute with a given value, I will allow you to override that value by specifying key.attribute equals value in the service configuration file. Keys in this case are nestable, so if you have a hierarchy, you can go to a certain extent in overriding, but there is one setting, and that's the routing configuration, which has a pretty complex structure. It's actually kind of a dictionary, and that's impossible for me today to, by convention, map to a certain service configuration setting, right? Because you just simply can't fit it anyway into the model. So that's the only setting I know of so far that you have to specify in appconfig, but all the others are specifiable in service configuration file. And as I said before, if you don't specify anything, I will just simply make assumptions and give everything a default value. Basically, everything has a default value besides those parts of Azure that do not have a local development counterpart, like, for example, the service bus. In that case, I do force you to specify your key and your username. But that's basically the Azure configuration source. So you can configure it partially in appconfig if you think this is something that doesn't often change. And for those things that do change often, like connection strings and number of threads or whatever, you can override those in the configuration file. For diagnostics, I lean on Log4net. Log4net is mainly there to do formatting of messages and stuff like that. But I will output all of the message or all of the trace and log messages directly into the diagnostics manager. It works in both ways. The old style where you had to configure the diagnostics manager in code, and also since SDK 1.3, I believe, the WAD CFG configuration file. If it detects the presence of an existing diagnostics manager, it will just simply play along with it. If not, it will start a new one. In order to control the settings when starting a new one in your service configuration file, I used the same naming convention as that has been used by Microsoft for its diagnostics plugin. You will recognize the diagnostics connection string plugin. That one is by default actually available in most solutions. If you start a new one in Visual Studio, it's already there, so I just reuse it. For the other specifications, I allow you to use the same namespace for the level, the log level, the layout of the Log4net configuration, the scheduled transfer period, and also which event log should be copied by Diagnostics Manager. I do prefer you to use the configuration file, of course, which is a lot richer in options. Something specific to talk about here. Yes, there's one little detail which is the case today, but which might change depending on input that I get from people using it. But I will override the log level of the diagnostics manager to verbose always, and I will control logging with the Log4net engine. This might cause problems for people who will build applications on top of NServiceBus, but who will not choose to use Log4net, because in that case they will always get verbose logging. Okay, so something that I'm aware of and something that I might change from configuration perspective. But today it seems to me that this makes most sense for me. But then again, I'm a Log4net user. Okay. So if you get any feedback or pushback on that, feel free to pass it back to me. Okay. From queuing perspective, we have a couple of options. One is the Azure message queue. And take note that all of the first lines are actually the method that you would call on the configure class, right? So if you want to configure it manually, that's the method that you need to specify. The Azure message queue will use storage queues as an infrastructure. I will emulate transactionality with, of course, peak lock mechanism. If you ever look through the code, you will see transaction scopes and those kind of things. Do not be mistaken, these will be translated to peak lock mechanisms, okay? So those things actually don't do anything, but it's just a convenient way to for me to specify when and where messages should be deleted or sent. There is also an implementation of a backoff mechanism in order to save money. It's a linear backoff. By default, it's configured if there is a message in the previous read which is processed, then it will automatically read again with no delay. If there is no message, it will delay incrementally with 50 milliseconds, and the maximum wait time will be 1 second by default. So in terms of money, this means that one idle NServiceBus process will consume about 10 cents per day. Okay. This is all reconfigurable, so if you want more aggressive reads, go ahead. If you want slower reads, go ahead as well. But I personally feel that the default is quite okay for myself. It also implements batching. NServiceBus itself implements send batching, which means that if you send 10 messages to the same destination at once, it will wrap them into one physical message and send it as one big message, in fact, if the queue size allows. But also the message queue itself is capable of reading in batches, just using the storage queue mechanisms. And with that combination, you can actually get quite a good throughput for those places that you need it. Furthermore, you can also specify whether or not a physical queue, a physical storage queue should be created per instance, or that one should be created for the entire row. By default, it will create one for the entire row. Configuration settings that you can specify are the connection string. By default, this will point to development storage. So if you don't specify it, you will end up with development storage. You can also set the message invisibility time. By default, this is 30 seconds. But I do multiply it by the batch size. Because when I read multiple messages at the same time and people assume that they have 30 seconds to process it, they might make the assumption that if there are 10 messages, that every single one of them gets the 30 seconds. So that's why I multiply. You can of course change this. The batch size is by default set to 10. If you set it to lower, then also the invisibility time will effectively become lower. The peak interval option is the backup mechanism. So this is the interval that gets added to the peak operations. By default, this is 50 milliseconds, I think. And the maximum wait time on idle is set to 1 second by default. Queue per instance is a Boolean which allows you to specify whether or not NServiceBus should create one queue for every instance or just simply one queue for the entire row. Okay, so that's when you use storage as a queuing mechanism. You can of course also use fabric message queues today. Granted, this is the last addition that I did to the framework when the fabric message queues got into production, so I have not really been able to test this piece a lot. But as far as I see it today, it also works with semi-transactional way. Correct me if I'm wrong, Clemens, but you also support true local transactions. Is this correct?
Yeah. I can. So let me pitch in here. So we support peak lock, and that's the primary mechanism. We support local transactions to group multiple message sends or receives, but that's and also setting the session state in that transaction. But it's not an enlistable transaction, so you can't do a coordinated transaction with our queue, because that would mean that we would subject our locks to your coordinator. Mm-hmm. We can't do that because it's shared infrastructure.
Okay.
And
so
also, I understand that there's a naming clash, but I wouldn't call this a fabric queue. I would call this something else.
Oh.
Because it's a service bus queue. I'm just saying.
Okay.
And then also, since it's a queue, right? So I don't know whether you're going to get the topics separately. But it's well worth considering splitting up the send and receive side into two separate things. So you can make this transparently work with topics and queues, just saying, as a comment.
Well, internally, in NServiceBus it is split. So I call it here a queue, because that's the old school version of V2. In V3 we have senders and receivers separately. So we can perfectly do topics, but today I do not have an implementation of topics yet. Okay, so I currently it's only the queues that I use, because I still have a couple of questions for myself, for Uri, and probably for you as well, on how we can translate the subscription store to the subscriptions in topics. But that's probably a separate discussion.
Yeah, we can talk about that separately.
We can talk about that another time. Okay. So the semi-transactional peak lock mechanism is probably the one that's going to stay then, and also support shared and per instance creation of queues. What I did not implement, because I don't know the billing model of the queues yet, is backup mechanism. As far as I see it today, there is no need, because today it's free basically. But in the future this might of course change depending on what Clemens' team or the billing department decides. But today it's not there. With regards to configuration settings, there are two required configuration settings here, and that's the issue name and the issue key. Okay, there is no default setting that I can provide here, because there is, as far as I know, no counterpart on-prem to do a fabric queuing. The other stuff is, the issue name is defaulted to owner. It's the issue key and the service namespace that is not defaultable. The service namespace is of course the namespace that you received or configured in Windows Azure Fabric. The log duration is also set to 30 seconds, similar to the message invisibility time in storage queues. The maximum size in megabytes is by default set to 1 gig, overridable to the 5 different options of 1, 2, 3, 4, and 5 gigabytes as specified in documentation. Duplicate detection is by default off. Sessions are by default off. The default message time to live is, I think, set to infinite, or at least whatever int46 max, whatever it was. That letter expiration is set to false, because NServiceBus actually has its own error or that letter mechanism. But I do not see a reason why they can't be used in conjunction, so you can perfectly put them on true if you want to. Duplicate detection has been set to the default as well, which means off. The max delivery count has been set to 5 times, also to conform with how it's done in Azure storage queues. Now you do need to pay a little bit of attention here, because this is a pretty special historical property that is configured on the MSMQ configuration section if you want to change it. This is still a little bit of a quirk that we still have, but it would require a lot of refactoring of a certain part of NServiceBus to change that name. So currently it's still MSMQ configuration file section to specify it for storage. Batched operations are by default on true, I think, and queue per instance is by default on false. But of course all of these are overridable from both webconfig as well as the service configuration file. Okay, so those are the basic types that you will always need, and you will probably always need to configure storage, configuration, and queuing. What is more optional only for certain types of roles or implementations is a subscription storage. So if you want to do pub-sub communication, we need some kind of durable place to store it. In Azure we have in theory 3 options. I have only specified 2 here because those are the only 2 I've tried. But the first option is subscription storage itself. You enable that by specifying Azure subscription storage as a method. This will do some trickery using an Hibernate over table storage. So I wrote an Hibernate driver that can run on top of table storage instead of on top of relational database. And that way I could reuse a lot of the old NServiceBus and Hibernate related code for NServiceBus in order to implement subscription storage. By configuration options, you have 2 things that you can configure. It's one, the connection string, and secondly, whether or not NServiceBus should automatically create schema. Create schema in terms of subscription storage just simply means create table. But it's by a convention, old name in this case, and by default it will be set to true. So if you don't do anything, NServiceBus will configuration your subscription account with the correct table, and it will do it all magically. Okay. Furthermore, you can, as a second option, you can also use SQL Azure. In this case, it's again an Hibernate pointing to the regular SQL driver from an Hibernate. I tested this one, and it seems to work pretty well with SQL Azure. The only thing that you need to change here is the connection string to point to your SQL Azure instance. And from there on, everything should also magically happen. Creation of tables, etc. is also enabled by default. The third option that I mentioned is RavenDB, which is actually the default by today for NServiceBus to store its subscriptions. But even though it is configurable in Azure by mounting a drive for RavenDB in every single instance, but personally I think this option is not a way to go if you want to make your system as simple as possible for developers. They can, of course, they can do it themselves if they really want to. They just have to specify that they want to use RavenDB as a store. But it's not something that I want to go. I don't want to go this route by default for NServiceBus on Azure, because I do think it's quite a harsh requirement for every single instance in a distributed application to have a second disk coming from storage. Okay, so those are the three options that we have to store subscriptions. For sagas, we also need to have several stores. Again, we have the three same options to store our data. And again, it uses for both of the storages that I promote. It uses an Hibernate, right? Because sagas, they do have a certain unknown schema for me. So I don't know what kind of states people want to track in the communication with different partner instances. I don't know. It depends on the business. And Hibernate is pretty powerful in being able to configure itself and to also create database schemas and in this case also table storage tables, and it reflected from the schema of the objects themselves. Okay, so in the past it used Fluent and Hibernate. Today we have an Hibernate version 3.2, which also has this auto mapping feature. I use that to figure out what the structure of the Saga persistence object is, and make sure that the table storage, or SQL Azure in this case, is configured appropriately with the correct tables, and etc. etc. So we don't expect users to create tables for storing their sagas, and NServiceBus will figure it out what it should look like. This does come for table storage with limitations, of course, right? You can't do decimals, and you can't create very complex hierarchical or relational structures. But it's my experience that usually this isn't the case. Usually these are quite flat with only a couple of very often value objects that are associated. So this is perfectly translatable to table storage. Again, you can specify the connection string, and you can also specify whether or not it should create a schema. By default it will. So this is the configuration that you need to do for table storage. So you have to enable sagas first. It's a .sagas method. And then you have to specify which persister you want to use. It's called Azure Saga Persister. And then this is a little bit quirky, but you also have to specify an Hibernate unit of work. There's something that will be changed, I hope, even before we release version 3, because I don't want the user to have to specify that. There's no real point. For SQL Azure, it's similar, except that the persister is different. In this case, the persister is simply an Hibernate. And again, it's a regular Hibernate configuration, an Hibernate properties section that you have to add, and all you need to swap out is the connection string. SQL Azure has the advantage over table storage that it's far more capable of storing complex Saga structures. So in case you have these complexities in your Saga models, go for SQL Azure. But it's my experience that most of them don't have the complexity. It's rather flat. In that case, I would promote table storage. Okay, then for databus, so for storing large properties like images and videos, I use block blobs from blob storage, which means that they are in theory limited to the 200 gigabytes, which is more than enough. The implementation in memory does not use streaming, so it will effectively copy the entire blob into memory before it pushes it to blob storage. This does mean that your blob can never be bigger than the size of the memory that you have available. Okay, so that's probably the limitation that you will run into. It will not be a limitation of storage. It's block blobs, so you can do uploads in parallel. I will upload them in blocks of 4 meg with default of I think 10 threads together. And on every single block there is a retry on failure mechanism. By default it will try to upload every block 5 times before it will throw in the towel. But of course you can specify all of those things. So in config settings you have the connection string, you have the number of retries that it can do. You can specify the block size, you can specify the number of I/O threads, and probably the most important one, you can specify the container in blob storage where it will store the intermediary files while transiting. Okay, and there is also an option for base path, which allows you to have prefixes in your file names to emulate folders if you like. But I rarely see people doing this, so by default it also doesn't contain any value. Okay. So those are the implementations. For now they're working for me. If they're not working for you or for any of your needs or your customers or whatever, remember that NServiceBus is actually simply a skeleton and everything is replaceable. So if you like to store Stagas in blob storage, you can. Okay, I just chose them for.
Can I ask a question?
Yes.
So you said that there's a constraint based on available memory on the client machine. Is that true?
Yes. Yes, we're looking into how we can swap to streams for the implementation.
Okay.
Today it's byte array, and we will pull the blob in memory.
Okay. Thank you.
Okay, so these are the methods that you can specify for configuring the bus, and also gives you an overview of how it works internally and which configuration settings that you can make. There is another important aspect within Azure that needs to be taken into account, and that's the aspect of hosting the bus. At first I only had one host, where every logical and NServiceBus process was dedicated to one worker role and entry point. Now, when talking to people and when talking to NServiceBus users, they basically declare me nuts because I figured out that they all design their systems very, very, very separated. Effectively, they create processes for one or only a few message handlers and run them all next to each other in isolation. So if you would translate that literally to Azure, every basic implementation would end up with 20, 30 roles. So that's something that was not really acceptable. That's why I actually provide two types of hosting today. One where you can dedicate an endpoint to a role, and also one where you can configure a role to not be a bus itself, but to actually load other processes, in this case from blob storage, and spin off child processes as regular executables on one instance. Okay. I learned that actually both make sense, so I still will support the dedicated one, and I simply support both. But depending on the type of app or application, one or the other will make more sense. And also, depending on the importance of a certain message handler or a certain group of message handlers, it might make more sense to host it dedicated and other side processes host them together on a shared instance. In order to define the hosting or the way that NServiceBus will react, I told you there is this concept of a role. The roles that I support are generically called as a listener and as a worker. I don't know if there's anybody who knows NServiceBus on-premises. On-premises you have as a server and as a publisher. But in fact, in Azure, these don't really make sense to me. Either you will just simply listen for messages and act upon them, or you will perform kind of an active worker pattern where you do work and then afterwards you also want to notify that you're done doing the work. So that's why I renamed my options. As a listener does not have any publishing capabilities and does not have any Saga capabilities, while as a worker has both Saga capabilities and publishing capabilities. So as a listener is for endpoints in your nodes, your maze of nodes or your grid of nodes, and as a worker is for anything in between. Right? Furthermore, there are more specific roles. As a host, that's the one that I will use to do the shared hosting. So that one will not start a bus, but will start loading additional processes from blob storage and run them as child processes. And then also has as a timeout manager, which is something that's required for Sagas. Of course, Sagas are keeping track of communication with partners. Sometimes it takes a partner too long to respond, and you want your Saga to continue or to abrupt or to whatever. And in that case, you need to have something that will call your timeout. Right? And that's what the timeout manager is doing. So that's a specific process that does nothing else but notifying Sagas that they are timing out. Okay. Next to the roles, there are also the profiles. I think I already mentioned these. So the environmental profiles determine the logging behavior, basically, which are development and production. Storage profiles is either you store everything on Azure Table Storage or you store on SQL Azure. And then you have communication profiles, which says with Azure Storage Queues or with Fabric Queues, and I will change the name if you like, Clemens. I can still do that now I'm not released. Afterwards it's more difficult. But I think I already explained these. And then finally, there is a special case whenever a role entry point is specified as a host. The host itself will not start a bus. There is a specific reason for that. Mainly to support the web worker pattern in web roles. Because NServiceBus is so magical or auto-magical, it will try to find all of the message handlers in its environment and load them all. But as both the process that hosts the website and the process that hosts the role entry point for a web role share assemblies, this would mean that both would be configured equally. And that's something that is not desirable if you want to go for the web worker pattern. So that's the main reason why I did not start a bus in the host itself for doing, for example, administrative control, etc. If you want to do administrative control, you would have to add an additional process with the capabilities in blob storage and just load it together with the host. You can configure a couple of configuration settings for the host. One is the connection string, of course, where it should find the blobs. The blobs are zips. zip files which contain all of the files required to run the process. So mainly is the content of the bin folder of a certain worker process, or sorry, worker role. You can also specify the container. So if you have configured multiple roles as a host, you can point them all to different containers, and in that way you can also control which child processes will be loaded by every individual role. The local resource is the folder on the disk of the instance where the files will be dropped for running. By default, I think this is called, I don't know, I think host or something. I would have to check. There's also an option to change the behavior of Azure instances for recycling on errors. By default, whenever there is an exception, an instance will recycle. When you load child processes, this may not be the behavior that you want. If you have 10 processes and you load an 11th and that one fails, you probably don't want to take the other 10 down. So that's why you can override the recycle behavior. The auto updates boolean allows you to specify whether or not the host should be pulling blob storage for new versions of the zip files. The polling interval is by default set to, I think, 10 minutes and can be changed by update interval property. And then also the processes, when they need to be updated today, are actually just simply killed. As everything is foreseen for that, and NServiceBus is quite capable of handling messages or interruptions during processing. So I just simply kill the process. But I noticed that sometimes it takes a while for the process to die. So that's why I've also added a property that specifies the time to wait until a process is killed. If the process does not die within that allotted time frame, I will throw an exception and recycle the role. Okay. I think this is by default set to 1 minute, I think. Okay, so those are the options. So you have a lot of implementations for NServiceBus running on Azure, and you also have some choices for hosting. Now I would like to give you a demo of what it actually does take to build a pretty scalable, distributable application using NServiceBus. And I will try to share my desktop in this case. I hope it works. Can you guys see my desktop?
Yes, now I can.
Yes? Okay, fine. So the application that I created is a Flickr clone, right? You can see it's online. You can try it out yourself if you like on nservicebus.cloudtab.net. Not everything is implemented, just simply what the application does, it allows you to upload a picture. It will then resize or create thumbnails of the picture in various sizes. Once all of those thumbnails are created, it will send a notification back to the user that processing is completed and that he can also see the changed picture here in the photo stream. So I'm just going to give you a slight demo. Probably my IIS recycle time has expired, but that's okay. Come on, IIS. I should have added a startup task for that. Okay, so I can browse for the picture. I conveniently added one to my desktop called Clouds. I will upload it. Once it's uploaded, it will be dispatched to background workers for processing. By default, it will create 4 different versions of a thumbnail. One is the original file size, a large one, a medium one, and a small one. We are waiting for the upload. The file has been uploaded. Now it's processing behind the scenes. I will entertain the user for a while with the spinning images. And once all of the communication is done, I will allow the user to go back to the photo stream, and normally there should be a small thumbnail here, which is one of the 4 thumbnails that is being created. It's pretty basic, simple sample, but behind the scenes there is quite a lot going on. And to show it in Azure, I will first give you the overview of the different instances and how it has been distributed. I have used the dedicated model. That means that for every message handler or every small group of message handlers, I will create a separate role. Okay. To save money, you can put these on the same role as a host if you like. I have one role for my website. You can see that it is duplicated, so it's in multiple instances. I have the photo processing role, which is the one that will do the resizing of the thumbnails. I also have 2 of those. I have the sharing role. The sharing role will wait until all of the processing of the image is done. Once all of them are done, it will send a notification back to the user and also update the photo stream entity that you can see on the home page. This thing will have to communicate with several events coming from the photo processor, so I will need sagas. A good friend of the saga is the timeout manager. It's not really required, but in a lot of cases you will see them jointly in solutions. So that's why I've also added a timeout manager role. So everything dedicated, everything running in multiple instances. And even though my IIS was a little bit slow, I think the time that it actually takes to process everything across the different instances is pretty much acceptable. Right? This is it. Okay. Now I'm redirected to another instance. Okay. So it's 4 roles, 8 instances in total, all playing nicely together to build a scalable version of an image resizer. Okay. Now maybe I'll switch back to the slides for a minute if I can find. How does this work? Can you guys see the slides again?
Yes.
Yes, okay. So the high-level architecture looks something like this. At the left you have the website instances, which will accept the uploaded image and then send a message through a storage queue in this case with an image attached. The image attached will move through the data bus, in this case blob storage, to one of the workers that is listening to the worker input queue. These have message handlers, 4 of them, for processing the thumbnails, and these will be executed in parallel inside the worker instances. Do mind that one message will be handled inside the same worker. Right? It's not that if you have multiple implementations for message handlers that they will be magically spread across workers. They will all be in one unit of work inside of the worker. Once those different message handlers inside of the worker are done, they will send an event or a message to the queue for the sharing service. Inside of the sharing service there is both a Saga implementation, which will actually wait until all of the 4 messages have been accepted. And furthermore, it will also have the publishing capabilities for publishing events back to the websites. The websites have been configured to each have a queue per instance. So this is the pattern that I see most, or at least have needs for most myself, when using caches inside of the instances themselves, so using ASP.NET Cache or something. If you would use a Fabric cache, it would obviously be a different model. And in the bottom, you can also see the timeout manager. I've added it as a small set of roles here because it's not so important for the demo, but they do play they play along with the sagas, of course. Okay, now back to my, where is it? Content, shares, desktop. Okay. So back to my desktop. I just want to show you around the solution and what it takes for the developer to actually build it. So we have here the MyFlickr solution with 4 roles in there, 3 worker roles and 1 web role. And I've added a couple of configuration settings to the cloud configuration file, including the connection strings. Make the remark here that I allow or require every individual component of NServiceBus to specify its own connection string over and over and over and over again. That is to allow the use of multiple accounts, or to use even multiple subscriptions if you like. Okay, so I don't think it will happen fast, but there are limits to the storage accounts. If you run into them, you do want to scale out in that way as well, so you can perfectly specify multiple accounts. Also, when sending messages in the web config, as I said, you do need to specify the name of a queue at a remote location. There you also have the option to add connection strings to the logical queue name, to append them, and in that case it will figure out that the queue is not in the same storage account as the receiving queue, and it will open a new client towards the destination queue. So I don't think there are any limitations on the amount of messages that you can send. It just depends on the amount of accounts that you can get hold of or that you have. Okay, furthermore, the number of worker threads in this case set to 1. You can increase the number of threads that are used to read from this queue just by changing this setting here. Okay. Something that you do need to keep in mind is that there are multiple licensing versions of NServiceBus. If you want to run multiple threads, you do need a license for the it's a little bit of a difficult story with licensing and related to Azure, because the licensing model that the NServiceBus team has today does not really match the cloud's model. So we always advise to either use the community edition, which means you can use it for free, but you can only use one threads per worker, but simply use the shared hosting option to have a lot of workers, or either buy the royalty-free version, which is just simply a set amount of money to buy NServiceBus basically, and then you can do with it whatever you want. You can have as many implementations as you want and go that route. All the other models don't really work out that well, as you could expect for something that had been designed originally for on-prem usage. Okay, so this is the configuration file. Don't think anything special. You can specify an error queue. You can specify the queue that it needs to listen on. You can specify some other settings like the number of threads that you can use. And then furthermore, you have a bunch of connection strings. Every component, so if you want to use subscriptions or you want to use sagas or whatever, it has its own configuration. Okay, so that you can use multiple accounts to split everything up wherever you like it. Okay, websites are a little bit special with regards to NServiceBus hosting. The hosting options, the as a worker, as a listener, They are specifically designed for running in worker mode, right? So you can use them from web role if you like, you can use them from a worker role if you like, but you can't use them today in a website. So in a website, you have to configure the bus manually. Here you can see the code for configuring the bus. It's a simply configure method, the Fluent API, similar or the same as to what I specified earlier in the slides. One little thing to keep in mind is that I do use external in the back end. I do use the diagnostics manager, and I do use the HTTP context, in fact, which are apparently not available in IIS 7.5 during application start. Okay, this is a known issue apparently, but they're not available, so I can't use them. And that's why I actually postpone the configuration of NServiceBus until the begin request. And in order to make this thread safe, I use a lazy construct to call the method only once during the first execution. Okay, that's an IIS 7.5 issue as far as I understood, that you cannot use HTTP context during application start, and that you can also not interact with the role environment. Okay, so that's the website. From the website we have a controller. It's an MVC app, and whenever I receive an uploaded file, I will create a new image uploaded message. I will set some properties, of which one is special, which is called the data bus property, which contains a byte array. And I just simply copy the file into the byte array. Now this is the part where I talked about that I hope to support streams one day, so that we can actually stream the file through. It would be a lot nicer. So this message is going to be sent to somewhere, to somebody who cares about the message. In the case of a send, you do need to specify explicitly to which destination a message needs to be sent, and that is what you do in the web config. You have a unicast bus config section with the message endpoint mappings, and in this case all messages defined in this assembly need to be sent to this queue, and all messages defined in this assembly need to be sent to this queue. Now here is a little bit of a difference. In this case, this queue is a destination for the send operation on the bus here. In the second case, this one is going to be used by NServiceBus to send subscription messages, because the website itself is interested in a couple of events as well. PhotoStream updated twice, and in order for the sending party to know that this instance is interested in those events, at startup it needs to notify the sending party that it is interested. So behind the scenes at startup there will be subscription messages where the website will subscribe itself to the origin of these events. Okay, so it will not send messages from this assembly itself, but it will send its interest in those messages. Okay, so that's basically everything that needs to happen in the website, right? All of the other stuff is just simply interacting with storage account, reading data from it, etc., making views, and so much more. But the only code that is required in a website is configuring the bus, specify a routing, do a bus send, and in case of, where is it? It's gone. In case you're interested in events yourself, also an iHandle messages. I want to return back to the message that is going to be sent whenever an image is uploaded. It's called image uploaded conveniently. Normally you don't have to specify this attribute, unless you decide to send certain properties across the databus. And in that case, you do need to specify to NServiceBus how long it should keep track of the file that is associated with this property. Okay, so it is in this case 1 hour. Okay, so that's the website. I think this is simple enough for most people to build. Then we have a couple of workers. The processing worker. In this case, the worker itself, I think this is the photo processing worker, yes. The worker itself inherits from the NServiceBus hosting Azure role entry point, and it has a configuration which specifies that it wants to work as a worker. As a worker means it has the capabilities of doing sagas and it has the capabilities of doing pub/sub, but I don't think it uses them effectively, so I could have said as a listener as well here. I do some trickery on to enable the databus. So I want to add a feature using I want custom initialization, and I also want to disable a feature. By default, everything auto subscribes for its message handlers, but if you know that you do not really want to play a part in a pub/sub communication, but only want to accept messages sent directly to you, you can disable auto subscription by specifying do not auto subscribe. You can find 4 message handlers here, one for the last thumbnail, one for medium, small, and the original file. And these implementations are basically just an I handle messages implementation, and to keep the communication chain going, there is also a response. Yeah, this is a bit overkill here. I could just simply have said new large thumbnail created with those properties, but something that I might tell you, which is interesting, NServiceBus has the capability of sending messages that actually do not really exist. If you just simply have an interface specified, you can ask the bus to create an instance of the interface, which also means secretly create me both an implementation as well as an instance, and it can send that. So you don't really have to specify full types if you don't like. You can just simply define message contracts as interfaces if you like. But in this case, you can obviously don't do new. You have to use the create instance option. Okay, so this one will just simply create a new thumbnail. It will store the thumbnail, and then it will send the message forward to the sharing service, and there are 4 of those which will send them separately, and I don't know in what order. Okay, so that's the important part, is that I don't know in what order. Okay, I want to close all these documents. In the sharing service, there is a message handler which is actually a saga. And a saga is something, or is a stateful object, and the state itself is defined in this object here. It's called thumbnail creation process tracking, and it has some simple properties which will track names of files, locations of files that have been resized. Now, because I don't know in what order the messages will come in, the saga can be initiated by any of the 4 messages. And in order to specify an initiation message, you use a special version of I handle messages of T, which is called I am started by messages of T, right? Specify only those message handlers that can actually create a new instance of the saga as I am started by messages. All others that you might have across the lifetime of the saga are just simply I handle messages of T. Okay, so those are conceptually the same as a regular message handler. Then there is one more required step in the saga, we do need some way of correlating all of the different incoming messages with the Saga state itself. And in that case, we as an NServiceBus team have chosen not to push correlation IDs or management of the correlation IDs to the user, but we will allow them to specify business properties that can be used by the Saga infrastructure to determine whether or not a message belongs or should be handled by a certain Saga. So in this case I use the image ID business property, but you can have far more complex constructs here in these lambdas, which will later be resolved by the nhibernate link provider to figure out which Saga belongs to which message. Finally, the lifetime of a Saga also needs to be ended, and in this case it ends when all data is available, so when all 4 messages are have been accepted. And if that's the case, I will complete it. I will store the photo in the photo stream. I will send a publication to all of the websites that the photo stream has been updated, and I will mark the Saga as complete. Mark Saga as complete actually means delete all the state of the Saga. Okay, we simply throw it away. We do not keep track of the Saga itself after it has been completed in the current implementation. Remember, if you want to have that, you can provide your own persister, which derives from the one I provided and which does not do the actual delete. If you want to have timeout, all you need to do is override the timeout method and specify at one place, where did I put it? Here. Should have put it everywhere actually. But you can call a method called request timeout, and you just simply pass in a certain amount of time that you want to have the timeout manager wait before it sends you a timeout message.
Can I ask a question?
Yes.
How do you do failover? So if this instance dies.
Yes. If this instance dies, so what happens, we are in a semi-transactional scope here. So all of these message handlers, whenever a message arrives and it dies, the file or the message will not be deleted from the queue. Okay, after the specified timeout, the message will obviously reappear, and then will be picked up by another instance for processing again. Okay, so if it dies, that's okay.
So I think the question is presumably, since you've been talking about scale, presumably you will have potentially have a larger number of backend processing nodes will go and process Sagas.
Yes.
So the question is, if one of those dies and goes away or hangs,
yes,
is there a mechanism to take that Saga and fail it over to a different node?
Oh, I see what you mean. In this, the Sagas are actually, with respect to the instance, they are stateless. Okay, so their state is stored in durable storage and in table storage in this case. And whenever one message is handled, it will be removed from memory from that instance, and it will be pulled back on another instance whenever another message of the Saga arrives. And that magic happens through this thing here, where for every incoming message there is a way to find the Saga in the Saga storage. This of course poses new problems with regards to concurrency, right? What happens if this message and this message arrive on different instances at roughly the same time? In that case, I use the ETAG mechanism to do optimistic concurrency, which actually means that the second message processor would throw an exception because the data has changed, and the message will reappear on the queue and be processed again. This for very large sagas or for very high concurrent processing, this might indeed pose a problem with the default implementation of using the e-tags. But I cannot decide for the user what is acceptable in terms of concurrency in its saga state for him. So if a certain user of the framework does want to support very high concurrent sagas which live on several instances and does or wants to allow some kind of overlap in the data, which is perfectly possible if the properties have nothing to do with one another, then they should provide their own saga persister. Does that answer the question?
Yes, it does. Thank you.
Okay. So the important message here for sagas is that they are not tied to a specific instance. They can live at any moment, anywhere. Okay. For the timeout manager, there's a similar problem. There are multiple instances of the same timeout manager, so they would obviously all decide at the same time to send a timeout message. In order to prevent that, I use leases on blobs in order to determine which of the timeout managers is allowed to send the timeout message. Because otherwise the timeout method would be called once for every timeout manager, and that's something that we do not really want. It's not logical for the user. Okay, basically that's it. So you implement the host or the bus itself, either manually with configure or with a profile and a role. You implement sending or publishing. You implement a bunch of message handlers which are in assemblies discoverable by a bus. And between them you have contracts. That's basically it, with some configuration that you optionally can specify, except for the routing information. So that's it. It's my part of the talk. You can play with all of this. Everything is open source. You can find it on GitHub. I'm not sure if I have the... No, I don't. So it's github.com/nservicebus/nservicebus. There, for every individual component, there are also samples in the framework. This sample that I've shown you here today is not yet in the samples collection. The reason for that is that I actually used Flickr's layout, which turns out to be against their policies. So I will have to change the layout of the site and probably the name as well before I can actually add it as a sample. Okay, but everything, you can check everything on GitHub. Just pull the latest version, look at it. If you have questions or remarks or whatever, you can always send them directly to me or any of the other NServiceBus team members. Are there any further questions with regards to NServiceBus or any feedback that you want to give me, positive or negative?
We had apparently 5 people from the ServiceBus team, from the Microsoft ServiceBus team on here, so on behalf of all of us, thank you. That was very informative.
No, thank you. Any other questions? I have a final call out to you guys. This is all new, right? NServiceBus. This will be the first NServiceBus version that will be completely running on Azure, basically. I already have a few real customers who are building systems, but there are only a few. So any feedback, any feedback from anyone is actually welcome at this point in time. to see where there might still be issues or might still be holes in the framework, or there certain type of default processes that are missing or whatever. If you see anything of that, I would really appreciate the feedback. I also think there is a Q&A question. Here is a question. Okay, right. Bill had a problem with his audio apparently, but that's okay. Anybody else? If not, then I thank you for your attention, for listening for 2 hours to me. I hope you see how NServiceBus and Azure can play together to make it simple to build distributed applications. All right, thanks everyone.
Thank you.
Thank you, Marcel.
Bye.